Greetings. Greetings, M Squared here. Today we are going to talk about solving quadratic equations using factoring. And to do that, we are going to remind ourselves of the zero property rule. Before we get into the zero property rule, let me remind you that when we solve a quadratic equation, or any equation for that matter, we are finding the x-intercepts. We are finding where the graph crosses the x-axis. And to do that, we should remember that the equation for the x-axis is y equals 0. So I'm trying to find out when y is 0, what x is. What are the x's? And remember, in quadratic equations, it's U-shaped, so it could have two x-intercepts. It could have no x-intercepts if the vertex was above the x-axis and it was opening up, or below and opening down. Or it could just have one x-intercept or solution. So keep that in mind as we go through. Let's talk about the zero property rule. Most of us just know it. If I said, I'm thinking of two numbers and I multiply them together and I get a 0, you would obviously know that one of them would have to be 0, because the only way to get 0 when I'm multiplying is if one of those, either A or B, was 0. So that's the whole premise for what we do when we set up, when we factor a quadratic expression, because we're going to say it equals 0. We're going to try to find out what values of x it equals 0. And to do that, we're going to get two binomials that are multiplied together, because if two things are multiplied together, one of them has to equal 0. So let's just remind ourselves of this little thing. If I have an expression that says 6x equals 0, okay, I'm going to kind of do this simply. Two things either have to happen. Either 6 has to equal 0 or x has to equal 0. Well, I know 6 doesn't equal 0. So the only other option to get 0 is that x has to be 0, therefore x equals 0. Now I have two expressions, the same thing as I had over here, right? Two expressions. It's just that now one is x and one is x minus 7. One of the best things you can do when working with algebra is get used to having a binomial in your mind representing one number. So x minus 7 represents one number. It looks like two things, but because it's in those parentheses, we have this times this. We're going to think of this as one number. And once we find x, it's easy to figure out what that number is. So if this is true, if x times x minus 7 is 0, then either x has to equal 0 or x minus 7 has to equal 0. Now my goal is to find out what x would be to make that true. Well, they did this one for me, right? X equals 0. So of course x equals 0, or x minus 7 equals 0. Some people automatically know that, hey, if I put a 7 in there, 7 minus 7 is 0, because that's the opposite of negative 7. But if you don't, it's okay. All you have to do is solve for x by adding 7, the opposite of that, to both sides, and we get x equals 7. So my other intercept, my other solution, my other root or 0, those are all words we use for solving, is 0 or 7. So 0 and 7 work. They work in this equation because if I put a 0 in for both of those, I get 0 times negative 7, which is 0. Or if I put a 7 in, I get 7 times 0 equals 0. They both work. All right, next. Now I have two binomials, but remember, we're thinking of these as one thing. That means we have to either get x plus 2 to equal 0, or we have to get 3x minus 2 to equal 0. So again, if you want the shortcut, I'm going to tell it to you in a minute. But if you don't know the shortcut, we just do the opposite. We subtract 2 from both sides, so that means x has to equal negative 2. Or we add 2 to both sides, which is the opposite of minus 2. We get 3x equals 2. Then we divide by 2, and we get x equals 2/3. The shortcut is just doing the opposite. So if you see x plus 2, you know that the only thing that can make a 0 is if this was the opposite, negative 2 plus 2, so x is negative 2. And then over here, it's the opposite of this divided by that. Because look, at the end, you have to divide it. So you just say the opposite of 2, negative 2, which is 2, divided by 3. That's the shortcut. We'll do a little bit more of that. Okay, so if we were in class, I would tell you to do this. So I would ask you to pause and then do it and come back, press play, and see if you're right. All right, so we get either 2x minus 1 equals 0 or x plus 5 equals 0. If I use my shortcut, I do it the opposite of 1 over 2, or the opposite of 5 if there's no coefficient other than 1 there. So those are my answers. If I do this one, either x has to equal 0, or 3x minus 5 has to equal 0. That one's already done for me. So it's 0 or, and then again, my shortcut, the opposite of this constant term divided by the coefficient of that linear term. All right, next one, either 2x plus 7 equals 0 or 3x minus 2 equals 0. We already had a 3x minus 2. So 2x minus plus 7, so I do the opposite of the constant term divided by the coefficient of the linear term, and then over here, the opposite of that divided by that. So those are my two zeros. So now the reason those were really super simple is because it was already in factored form. So what's really important when you're doing your homework is that you realize which ones are already in factored form and which ones are not in factored form. So when solving equations by factoring, you need to get the quadratic equation in standard form and then use the zero property rule. Okay, and then I should have said, and then factor, and then use the zero property rule. Because we have to have it in factored form or the zero property rule doesn't fit or work. Okay, so we're going to try some of that. All right, so the first thing I'm going to have you do is just tell me whether it's factored form or not. Notice that some of them are equal to 0, some of them are not, but what is factored form? That means it's already factored, two lovely little binomials multiplied together equals 0, or x on the outside multiplied by a binomial that equals 0. So you can pause and do that. I'm going to go ahead and tell you, I'm just going to write it up here. So is this in factored form? Yes. I have two parentheses. That's in factored form. Is this one in factored form? Yes. I have two parentheses. I can't see both sets, but that's because of that squared, but that's definitely in factored form. Is this one in factored form? No, it's not. Nor is it in standard form, because in standard form I'd have to have 0 on one side. So this is none of those. This is not in factored form. See, no parentheses, but I do have 0, so that makes it standard form. This one, no parentheses, so it's not in factored form, and no equals 0, so it's not in standard form. And here again, I have factored form. Now that's important because if it's in factored form, you're ready to go. You're ready to use the zero property rule. If it is not in factored form, you've got to get it to look like that before you're ready to use it. But the first step would be standard form. So these two that aren't even in standard form, first we've got to get them in standard form, and then beyond that, we're going to use factoring to get it in that factored form. So let's go. If it's already factored, we're just using our shortcut, right? X equals 5 halves or x equals 11. So I just took the opposite divided by opposite. You can kind of see divided by 1, but I don't need to write that. When you see it like this with one parenthesis and squared, that's that kind of parabola that just touches and comes back up. So there's only one x-intercept. How do I get this to be 0? Well, I need it to be -5, because -5 plus 0 would be 0. Squared is 0. So I only have one set to do if I have a binomial to the second power. I just have to do that once. Now this one I need to get in standard form. So I do that by adding 4x and subtracting 5 to both sides. Now that moves everything over. You can kind of think of it as when you move something from side to side, you just change the sign. You can do that too. I kind of skipped a step there. Hopefully that's not too confusing. And now I have to factor it. Notice I have my equal 0. So here's where I have to find two factors of -5 that add up to 4. Well, that would be 5 and -1. They multiply to get -5, but when I add 5 and -1, I get 4. So we know that our factors are x plus 5 and x minus 1. Let's check. X times x, yes, that's x squared. 5x minus 1x is 4x, correct, so we're good. 5 times -1 is -5. So once we get it in factored form, then we're ready to solve using our zero property rule that says either this one or this one must equal 0 in order for them multiplied together to equal 0. And I just use my shortcut again. So x either equals -5 or 1. And those are my answers. All right, let's try this one. It's not in factored form, but it is in standard form, so I'm ready to factor. What I notice is there's only two terms. It's not a quadratic trinomial, it's a quadratic binomial. And when I have the linear one and the quadratic terms, what I want to do is see if there's a greatest common factor, which really you should always do. check the greatest common factor first when you're factoring. Well, I see that 3 goes into both 6 and 3, and x goes into both x squared and x, so I know that's my greatest common factor. And then to find out what goes in here, I just divide both of those by 3x. So that gives me a 2x minus 1. I can double check. That says 6x squared. That's negative 3x. So we're good to go. So either 3x equals 0 or 2x minus 1 equals 0. Again, there's nothing that you can multiply by 3 to get 0 except 0. So I know x has to equal 0 there. And this one, if I put a 1/2 in there, I get 1 minus 1 equals 0. Or we can use our little shortcut, which is the opposite of that constant divided by that. So there's my answers there. All right, just 2 more. So 5x squared minus 2x equals 7. It's not in standard form. So the first thing I have to do is get it in standard form. So 5x squared minus 2x minus 7 equals 0. Now I have to find 2 factors. Remember, it's 2 factors of AC, that's negative 35x squared, that multiply to get negative 35, but add to get negative 2, or the B. So that looks like negative 7 and 5 will get me negative 2. Now we use the box method. There's lots of different methods for that. I'm just going to do the guess and check real quick because this is prime, so I know that the only way to get a 5x squared is here. That's 7. I know the only way to get a 7 is 7 and 1, or 1 and 7. And since I know I have to have 7 and a 5 separate, I know that has to be 7 and that has to be 5. So I put my negative there for the negative 7x and my plus there for my positive 5x equals 0. Remember, I'm not done. When I'm factor, that's just the hint that, okay, now it's ready, time to use the zero property rule. So I say x equals 7/5, right? Or negative 1. Okay, last one, and this is already factored, so that makes it nice. It doesn't really matter if 0 is on the left or the right. We're just going to say, okay, we're ready to use our zero property rule, so x equals the opposite of negative 4, or the opposite of 8. And we are done. So for your homework, you will have to explain the zero property rule in your own words and include how you would use that to solve equations. So we kind of talked about that a little bit. Good luck doing that. M squared signing out.